And that's really what the CIOs, the CFOs really focused in on, was actually, I know, most of my servers have got 95% free capacity, they only use 5% of their capacity. So can't I actually put 20 of those workloads on one server, get rid of 19 and just have one that's running flat out? That's really sort of the fundamental concept of contention. You know, let's take 10% workloads and move that onto one server running at 100% and get rid of the other 9 servers. You need to plan around that carefully. So we mentioned, in the 5% example, you could consolidate 20 to 1. So that's an example of a contention ratio. I can take 25%, that equals 100%. I can get 20 to 1. Realistically, what you would probably do if you were taking that approach is contend on a 10 or 15 to 1 basis. So if that really was your average CPU usage, you would still give yourself some headroom, some room for manoeuvre if things were busy. And that, in older environments where they have dozens of old servers, rackloads of old kit, was a really good approach to getting rid of those old servers, cutting down power and cooling. The challenge you have is when that 5% suddenly jumps up to 60%, and there isn't enough 60% to go around. So what happens in those instances is I could potentially be trying to get 1200% CPU utilization in total out of my server at this point, if I had 20 virtual servers all wanting to use 60% of total CPU resource. The problem that we get then is what I call bad contention, and this is where the virtual servers no longer always have every bit of resource they need freely available to them. Previously, if we were consolidating on a 10 to 1 at 5%, half the server would never be used. So it would mean any virtual server would always have every bit of access it needed. There was no latency, there was no time slicing, there was no tricks having to be done to find resource in a hurry. When we move to this bottom scenario of bad contention, the hypervisor, which we'll see in a moment, is the piece of controlling software for virtualization. That's now having to control this access to the resource. There isn't enough to go around, but it's promised everyone there is. So it's now having to allocate on a priority basis. You think you've had this resource, but I'm going to make you wait a little bit until it really becomes available. And ultimately, the bottom bullet point there is the problem that you will have in high performance and production environments when this bad contention happens. You can no longer be guaranteed access to the resource, so you can't guarantee the consistency of your performance. So that's probably sort of the good side, the bad side. People only ever talk about the good side. People also, as we'll see in my example, they only ever mention CPU usage. There are a dozen other factors that you need to measure and calculate before you decide how you contend. But that's really the media story. If you're new to virtualization or a CFO says, why should I virtualize? That top one is the story he'll get told. You can get rid of 19 servers if you make one server really, really busy. So I think, as I mentioned to somebody asked me in the break, what makes a good candidate to virtualize a server? So people often ask me, what's the biggest server you can virtualize? You can't talk about big. I could give you a really small SQL server, I'm sure you all have one, or a small web server, reporting services or integration services host. But it's got a tiny footprint, but it runs flat out at certain times of the day. At the other end of the spectrum, you might have a massive server running a data warehouse or reporting databases that's massively over-specced, a lot more resource, but a lot lower utilization. So they're very, very different types of workload when it comes to sort of saying, well, what makes a good candidate for virtualization? So people often ask, is it that small, medium, and large? And the actual answer there is it's more about the workload. So it's about quiet, active, and busy. So if you're a web developer and you're being told that you need to host your software on virtual web servers, you need to start to consider actually, well, what's the workload? Am I likely to run into resource and contention issues because I know my web server is going to be really, really busy? Or actually, is it just quiet and it doesn't really notice too much about the environment it's in? So they're the terms that I use. They're very, very different in terms of their meaning to small, medium, and large, but they are quite measurable, or we emotionally know if a server feels quite active or busy. And then really, my experience to date, Virtualizing these quiet servers, so this could be your HR system, your expenses system, your entry card logging system. That's what I would call a quiet system. Virtualizing them is the norm now. You would never physically buy a server, a physical server, to run a tiny little database application on, whereas 5 years ago we had to. So virtualizing those is the norm. Virtualizing your active servers, so this could be your finance system in a mid-enterprise company. It's quiet with a dozen data entry clerks for most of the month. There's a couple of busy days at the end of the month, but it's pretty generally happy with the amount of resource that you've got. Nobody ever phones you up to say it's slow. Everybody knows it'll be slow at month end, but that's the type of active server where we should be able to virtualize that if it's got some good virtualization practices behind it. If your virtualization admin, tells you he's going to virtualize your environment on the same day that he receives the manuals in the post, it may not go so well. If you've got an experienced IT team, it should go well. The red label I've got there for busy servers, so these are almost certainly going to be, the online e-commerce trading platform databases, the really busy transaction systems, 24/7. They're the types of environments which, when I see them, they always have locking, blocking, and deadlocking issues. They didn't scale. They've got poor indexing, high CPU. They're busy. They're a pain to manage and keep stable, even on physical servers today. And yet somebody says, wouldn't it be a great idea to virtualize them? You can virtualize them, but it will need planning. VMware and Microsoft with Hyper-V 3 and Windows 8, their marketing pitch now is you can virtualize anything. They have scalability capabilities in their software now that no workload is too big for the current generation of their software. That's probably not too far from the truth. If it's a well-structured, designed environment, their software will almost certainly be able to find and handle most workloads that you throw at it. So what we're saying here is that some systems will work fine, some won't, some will need planning. If people start to talk to you about systems that need to be virtualized, start to think about what do you call them quite active and busy, what's your emotional sort of feeling about how difficult they are to manage today. So I'll go through some terminology that some of you will know inside out, some of you might be new, sometimes some of you may not have seen the complete picture. So the guest server is Hyper-V's terminology for a virtual server, a virtual machine. This is actually, this is the virtual environment that runs its own instance of Windows that you all run, SQL Server, IIS, BizTalking, and there will be dozens of these in your virtualization environment. So that's really the end product of everything virtualization does, is giving somebody somewhere one of these. And that normally runs on a layer called a virtual machine manager. So in the bigger VMware environments, this used vSphere and it was controlled by vCenter. Microsoft had their equivalent products with System Center and Hyper-V Manager. So we had this control layer. This was really the admin interface into the virtual environment. And then we had our TIN, the physical layer. So this was 1, 2, 8 environments I worked in before had 256 host servers. So these were regular physical servers that you would buy from HP, put in a rack. But rather than installing Windows on them, in the VMware equivalent, you installed a piece of software called a hypervisor, and that is its own mini operating system that allows this host server to be controlled and run guest servers. And then to make things all really smooth in a mid-sized environment, you would then use a SAN that had shared storage that each of these could access. So is that useful for some people that have not seen that all in one slide before? I'm never quite sure if that is a good way of describing it. Most people only see this level. This is what sits behind it. You probably hear about the hypervisor, but this is really sort of the infrastructure. So why has designing platforms changed when we've moved from physical to the virtual world? So this is the bit which, ironically, most people overlook. They think that when what we had in the physical world, we can still apply the same design principles, and monitoring principles, management principles, troubleshooting principles to the virtual world. So whether you are an ETL developer, whether or not you're a database developer, whether or not you're a DBA or a sysadmin, you will have an interaction with one of these layers of the stack, typically, or you could be an end user coming into the top. In the physical world, we would have a server that did all of this. So we would have a physical box. We knew that every bit of resource in that physical box was only ever going to be used by anything further up the stack. So if we had 16 gig of memory in this server, Windows would see 16 gig of memory, SQL Server would see 16 gig of memory, and so on. And that made it really, really easy because we didn't have to worry about what anyone else did. The only people that could affect anything in this stack were other members of this stack. And we could, when we came to troubleshooting, we could look at each layer and we could look at this whole environment in isolation. The challenge that we have when we move to the virtual environment is that firstly we have a new layer, but also these three layers are now shared. So the big change that we have now is that somebody else's SQL Server engine could be affecting my server hardware performance, which then affects my SQL Server engine. So by having these shared tiers in the stack now, that totally changes our approach to troubleshooting, to capacity managing, and also saying, well, actually, where might the issue be? Before we were confident that the only people that can affect our behavior were us. Now I can have a really noisy neighbor that shares my host server, shares my SAN, and actually that brings down my application logic at the top. So that hopefully will help you visualize really that expanded stack, and also what is now shared, and not necessarily shared with good people that you're aware of what they're doing. So SQL Server and virtualization. I guess the slides up until now have all just been about generic virtualization. There's a reason for that, because SQL Server doesn't really behave very, very differently when it's virtualized. Most applications don't. Most applications, all they ever need is CPU, memory, and storage. As long as you give them enough of that, as long as you give it in a performant way, they will operate. SQL Server is no different. SQL Server is no different when that's running on virtual rather than physical. So SQL Server, when you start it up, it will detect or it will report that it's running on a virtual server. There is a DMV, sys.dmos sysinfo. Has some columns that tell you about the server type it's running on. There's a tiny bit more information about that in SQL Server 2012. It is purely read-only informative information. It does not influence any behavior. So SQL Server does not say, I'm running on a virtual server, so I'm going to give you new error messages. I'm going to enable some new features. It's not going to change any way that you interact with SQL Server or any of the error messages that you ever get, just because it reported that it ran on a virtual server on startup. There's one tiny little exception that we'll mention in a moment, but when it comes to you doing your day jobs, whether you use SIS, reporting services, or SQL Server, the very fact that you're on a virtual server is not going to change functionality. What it may change is your access to the resources that you need to run everything at the speed that you like. So that's probably the big change, is that it's far easier to have the resources that you need taken away from you. So there is one change. Hot add memory is a legacy, it's not legacy, it's in the product. So it was a feature that came out in 2005 Enterprise Edition. Hot add memory was designed for these massive servers that were going to run SQL Server that were the size of mainframes, that had 32 CPUs, 8 terabytes of memory or something crazy. And they were so huge, they were going to be up forever, they were never going to be restarted, and you could physically upgrade them in real time. So you could plug more memory into the server physically, you could flick a switch and then SQL Server would magically recognize the new memory that you just plugged in a few minutes ago and start using it. To do that, it had to have a couple of features in Windows to support that and in the SQL Server engine, and that was called Hot Add Memory. It kind of never really went mainstream. It was a bit like Titanium support. It was a great capability for an era of computing that was pretty low powered. So it went away. However, it does now get used by dynamic memory, which we'll talk about in a moment. So you will see some changes in the product groups delivery of SQL Server features specific around this area in SQL Server 2012, which I mentioned. So we mentioned earlier our monitoring has to change when we move to this virtual